In this video, I'll be discussing a quadratic function problem. Suppose that the quadratic function f(x) equals to x squared minus 4mx plus 2m plus 6 has exactly one root on the interval -3, 0. Find all possible values of m. So, for this problem, we know that this quadratic function has one root on the interval -3, 0. And then, well, we can obviously split this into two cases. For normal quadratic functions, where the discriminant, or delta, will be greater than 0, this means that there's two x-intercepts. But when delta equals to 0, there's only one root. And that root is going to be on the x-axis. And that root will also be the vertex of the parabola. Obviously, for this problem, we can't have delta less than 0, or there's going to be no x-intercept or roots. And that wouldn't work out. So now let's solve the first one, first case. So for the first case, it's just gonna be distinct roots. So let's draw a graph. We have the coordinate plane, and then we have O as the origin, then let this point be -3. So we have -3 less than the root less than 0. So this means that the root is in between -3 and the origin. So we should just choose a random point here. Then we can draw a parabola passing through it. Well, we don't know whether the parabola will be on the left or right of this root. I mean the other root, it can be to the left or right of this one. But then we can't really find that out either. And it doesn't really matter since we don't know the value of m yet. So to do that, let's just assume that it's to the left of the parabola. It can also be to the right of the parabola, then the conclusion we're going to make is going to be the same. So we pass through this point. Okay, now what conclusion am I going to make? Well, let's observe the two extremes, -3 and 0. Say when x equals to -3, well, the corresponding y value you see is obviously less than 0. But then when x equals to 0, that's the other extreme. Well, if you extend its parabola upwards, it's going to intersect with the upper portion of the y-axis. So y is going to be greater than 0. So now we can get that f -3 times f 0 is going to be less than 0 because they have different signs. And positive times negative equals to negative. So then, let's just plug them in and see what we get. Nine plus 12m plus 2m plus 6 times f0 is going to be 2m plus 6. So this will equal to 14m plus 15, 2m plus 6, less than 0. So, less than 0, so there's going to be of different signs. So now we split it into casework. First case, I, which means 1, is that 14m plus 15 greater than 0, 2m plus 6 less than 0. So then this we can get that m be greater than -15 over 14. And then m is going to be smaller, 2m plus 6 can be less than 0, so 2m can be less than negative 6, and m can be less than negative 3. Then the second case, 14m plus 15. This will be less than 0, while 2m plus 6 greater than 0. Get that m will be less than negative 15 over 14, or m is greater than negative 3. And obviously this case is going to have intersection. Well, the first one doesn't have an intersection, so this one will be not work. This we can get that negative 3 less than m less than negative 15 over 14. Now the second case, this will be repeated root, because when there's only one root for a quadratic function, we know that the two roots are repeated. And when there's only one root, it means that delta equals to 0, or the discriminant equals to 0. So we can mark this by a triangle, or Greek letters delta, which equals to b squared minus 4ac. Note that b squared minus 4ac refer to the coefficients of a normal quadratic function, or a standard form, which is ax squared plus bx plus c equals to 0. So in this case, b equals to negative 4m squared minus 4 times 1, 2m plus 6. So this equals to 16m squared minus 8m minus 24 equals to 0. Divide both sides by 8 to get that m squared, 2m squared minus m minus 3 equals to 0. So by quadratic formula, m equals to 1 plus minus 0, because now the delta equals to 0, over 4. No, square root of 1 plus 4 times 2 times negative 3. So this will be plus 25, plus 24. And then we'll get that 1 plus minus 5 over 4, which equals to 3 over 2, or m equals to negative 1. Then we check. When m equals to 3 over 2, well, fx will equal to x squared minus 6x plus 9. And then the root of this is going to be, so if you let this thing equal to 0, well, the root of this is going to be x equals to 6 plus minus square root of 0, because it's going to be 36 minus 36, so 0 over 2, which equals to 3. But then, since 3 does not belong to the interval, so not work. And then the final case, when m equals to 1, fx equal to x squared minus 4x plus 8. So x will equal to 4. Again, this will equal to 16. So 16 minus 32. Wait, and m equals to negative 1, my bad. Negative 1, so this is going to be plus 4x. And in this case, it's going to be minus 4. So it'll be 4, it'll be negative 4 plus minus 0 over 2. And then this will equal to negative 2. Works. Because it does belong to the interval negative 3, 0. So our final answer is going to be negative 3 less than m less than negative 15 over 14. Or m equals to negative 1. Because negative 1 does not belong to the interval. And then that will be the answer to this problem. The key point is that you have to identify the two cases, distinct and repeated. Then you have to draw a graph which is a common method to solve quadratic functions. You can get this conclusion. Then you have to solve the quadratic inequality. And for this case, well, you know that repeated roots have a delta equal to 0. And then you have to solve for this one. But then when you check, you find that only n equals negative 1 works. So that is how you get the answer to this problem. Thank you for watching.